I'm Bob Johnson, one of the 20 directors of the Enterprise Forum. We're all volunteers that basically work very hard to put on interesting and relevant programs in support of entrepreneurship. We've been doing this in Santa Barbara for 25 years. We got started in 1984. There are 24 chapters of the MIT Enterprise Forum worldwide, and Santa Barbara is the smallest town to have one anywhere in the world, which I think speaks to the vitality of the entrepreneurial activity in this town. Now, people are often asking me, why does MIT do this? Because it's obviously open to the public. And for nearly 150 years, MIT's mission has been to bring science and technology into being useful for mankind, putting it into practical use. In a recent report, the Kauffman Foundation, which studies a lot of entrepreneurial type things, found that of the 110,000 living alumni from MIT, that they have founded almost 26,000 companies, which, and these are companies that are still independent, which means they haven't been acquired. So companies like Digital Equipment and Apollo Computer aren't even counted in these numbers. These 25,800 companies employ 3.3 million people, generate over $2 trillion in sales, and taken together would represent the 11th largest economy in the world. So entrepreneurialism is in our sort of genetic code. We promote the entrepreneurial ecosystem all over the world. I'd also like to cite a couple statistics about MIT's role in our military and in our space program. ROTC has been at MIT since 1861. More than 12,000 officers have been commissioned from MIT, and more than 150 of them have become generals or admirals. And with the exception of the military academies, MIT has produced more astronauts than any other school. Before beginning our program, I'd like to acknowledge our sponsors: Riviera Insurance, Bank of the West, Radius Group of Commercial Real Estate, NASA Fix Harrison Company, Certified Public Accountants, Stradling Yaka, Carlson Routh Attorneys, Visus LLC, Web and Database Services, the Pacific Coast Business Times, CIO Solutions, and Express Employment. They are all premier sponsors. And then our supporting sponsors are DuPont Displays, Almarosa Wine, Mission Ventures, and NewsHawk. Without their help, we couldn't afford to do this. Our ticket prices are already about, I think, as high as the market would allow, and we lose money on every program we do. As you can see, we're videotaping this program. This is the 8th one that we've done on videotape. This program will be broadcast on Channel 21 a number of times in the next couple of months. To get the broadcast schedule, you can go to sbchannels.tv and then click on Channel 21, because they've got two, and then click on the on-air schedule. And now I'd like to introduce Dan Brooks, who put together this program as our moderator for the evening. Dan has been a director of the Enterprise Forum since 2001, and he's put on many great programs over the years. He's a project engineer with Montgomery Watson Harza, a large engineering and environmental consulting company. He's got a bachelor's degree from MIT and a master's from UCSB. Dan grew up in Lompoc, in the shadow of Vandenberg Air Force Base, and he's always been involved in the entrepreneurial economy of the Central Coast. Dan?
Thanks, Bob, and thanks for your help putting together tonight's program. I want to welcome everyone to 21st Century Space Operations, Challenges and Opportunities. The format for the program tonight will begin with a keynote address by Lieutenant General Larry James, followed by a presentation by David Maston, hopefully, who is the CEO and founder of Maston Space Systems, which recently won the X Prize Lunar Lander Challenge. And then Dan Burnham, the retired CEO and chairman of Raytheon, will join us for a panel discussion. So first, let me start off by introducing General James. He's the commander of the 14th Air Force Space Command and the commander of the Joint Functional Component Command for Space, which is part of the U.S. Strategic Command at Vandenberg Air Force Base. He leads more than 20,500 personnel responsible for providing missile warning, space superiority, space situational awareness, satellite operations, space launch and range operations. With that, General James.
Well, good evening. Thank you for giving me the opportunity to come down from Vandenberg Air Force Base. I must say it's a beautiful drive when you come down along the coast, and it's hard to drive back to Vandenberg when you get to Santa Barbara. But again, it's a great opportunity. I appreciate the opportunity to be here. And as an '83 grad student from MIT, it's always fun to come back and talk to other grads and alumni. So thanks for the opportunity to be here. I don't have any slides tonight, so I don't have to look at PowerPoint. But I did want to tell a small story. There were 4 engineers in a car driving along. Or do we have any engineers in here? You had a mechanical engineer, an electrical engineer, a chemical engineer, and a software engineer. So the car's driving along, and suddenly it stops. The mechanical engineer, they all look at each other, and he says, "You know, I think I heard some clicking in the engine. I think we have a rod problem. We probably threw a rod." Electrical engineer says, no, you know, I saw some sparks coming out of the dashboard. We really need to get under there and find some fuses and fix the electrical problem. And the chemical engineer said, no, the engine was chugging. I think we have some bad gas here. We probably just need to go find a good gas station, get some good gas, it'll be okay. Software engineer says, I know how to fix this. Let's all get out of the car, get back in, and it'll start right up. Do we have any software engineers who want to admit it? So I am here to talk about what goes on at Vandenberg Air Force Base. And obviously you live in the shadow of Vandenberg Air Force Base. You get to see the fruits of our labors often in terms of the launches that we do from the central coast here, headed into polar orbit primarily. Sometimes we go downrange with our Minuteman launches to test our ICBMs. But really there's a lot more that goes on at Vandenberg than probably most of you realize. Really, what we've done there is we've set up our headquarters for all DoD space operations. So if you think of global positioning system, if you think of military satellite communications, if you think of military satellite weather systems, our missile warning systems, all of those things are done from Vandenberg Air Force Base in terms of the command and control, the operational level command and control that goes on there. Really 2 organizations that they talked about, I'm not going to dwell on what those really mean, but the Joint Force Component Command for Space is under Strategic Command out at Omaha. Think of the old SAC, if you will, Strategic Air Command. That is what Strategic Command now is. It has responsibility for ICBMs, it has responsibility for space, it has responsibility for cyber warfare, intelligence, surveillance, and reconnaissance systems. All those things now fall under Strategic Command for our nation's defense. And then under that Strategic Command is Joint Functional Component Command for Space, which is what I am responsible for there at Vandenberg Air Force Base. So even though we do conduct launches out of Vandenberg, in reality we do all the operational level command and control from that location, providing guidance and direction to all the various DoD space organizations, whether it's in Colorado Springs, whether it's in Denver, whether it's the launch ranges out at Patrick Air Force Base in Cape Canaveral in Florida, whether it's all the tracking sites we have everywhere from Thule, Greenland to Socorro, New Mexico to Japan to Guam, etc. All those things fall under the operational command and control of the organization at Vandenberg Air Force Base. So that's really our bread and butter in terms of what we worry about day in and day out in executing that mission for our combatant commander, General Chilton at STRATCOM, and ultimately for the Secretary of Defense. And what I thought I would do in just highlighting some of the things that we focus on and that we think about is just a couple of vignettes that have happened in the last few years, actually in the last year. The first is a satellite collision. How many of you are aware of the Iridium Cosmos satellite collision? Probably a few of you. This was really the first time that we've had 2 satellites that have collided in space, and it happened about a year ago. It was February of 2009, and Iridium was an active communication satellite. The Cosmos satellite was an inactive, if you will, dead satellite that was launched by the Russians back over 10 or 15 years ago. And really no one was looking at the possibility of those 2 systems colliding. You kind of had the big sky theory or the big space theory, if you will, that space is a big place, and so we don't necessarily have to worry a great deal about that. One of the responsibilities we have at JFCC Space is to track objects in space. We're focused on all objects that we can see with our sensors. Frankly, we have the best space surveillance network in the world. The Russians have a network, the Chinese have a network, the Europeans have a network, but if you want worldwide sensor coverage to do tracking of objects and satellites and debris in space, we have the best. The United States and the U.S. Air Force, which operates that, is the best system. Back in February of 2009, we tracked everything, but we only did what we call conjunction assessments, or determining if two objects are going to collide, on U.S. government and DoD payloads, probably about 130 payloads on a daily basis that we would track, we would assess, and make sure there was no debris or no other satellite that was coming toward that satellite and create a problem. So on the ops floor that day, we had a young captain who received an email from the Global SATCOM Support Center, who had received an email from Iridium saying, Iridium 68 is no longer functioning. And, that happens occasionally. A black box fails or something else happens. So folks didn't necessarily get excited, but the young captain on the operations floor there at Vandenberg said, well, I've been trained to assess this and determine was there something else that happened. So he immediately tasked some of our sensors to go up and look and see, okay, when we expect this satellite to come in view, what are we going to see? Because we have the ephemeris sets, the element sets, and we know where they're going to be, 2 minutes out or whatever the case may be. So he tasked our sensors and determined that instead of, one satellite, there was a lot of objects where this one satellite should be. So wasn't necessarily part of his procedure, but really a forward-thinking young man, did a great job, said we need to go take a look at this since I want to know what happens. And that obviously instituted a lot of information flowing all the way up to the Secretary of Defense and the Joint Staff, trying to understand, okay, what exactly happened here? Was this Cosmos a dead satellite or not? Was there something intentional or not? And of course, we worked our way through all of those questions. And again, it was nothing intentional. It was two objects colliding in space, but got a lot of people's attention because they recognized that this could happen, and we probably need to pay a little more attention to this. So since then, we have been given additional resources at the Operations Center there at Vandenberg, additional people and analysts, as well as additional processors, so that as of the end of this year, we reached the milestone where we are now tracking and assessing all active satellites on orbit, and determining if there is any potential conjunctions of those satellites with either other satellites or pieces of debris in their orbital regime. And that's roughly about 1,150 satellites now that are actually active and transmitting a signal or performing some form of operation. And so daily, the folks at Vandenberg Air Force Base are doing that assessment. We are then, if there is a potential conjunction, and we have certain criteria at low Earth orbit, at geosynchronous orbit, that if you get within a certain distance, we will then notify the owner-operator of that particular system that you have a potential conjunction, and perhaps you may want to make a maneuver and avoid this potential conjunction. And so since February of last year, we've made thousands of notifications, and then there's been 56, as of today, 56 maneuvers conducted based on the information that was provided from the folks at Vandenberg to avoid a potential conjunction. And normally, especially if you're down in the less than 20-meter range in terms of a possible conjunction, a vehicle will normally maneuver just to make sure that they don't have any kind of collision in space. So I think that's been a very successful thing for us, and it's got a lot of attention, and a lot of people are relying on the assessments that are done from the folks at Vandenberg and this worldwide sensor network that we have. With that network, we track about 22,000 pieces of debris or satellites on a daily basis. That's generally what we're tracking on orbit today. As a result of this collision with Iridium and Cosmos, we added over 1,000 pieces of debris to that catalog just from this one collision. So roughly 5% of the total debris on orbit is now resulting from that. If you go back about 2 years ago, you may recall that the Chinese conducted an anti-satellite test, an ASAT test, with their SC-19 booster against one of their defunct weather satellites. They created over 2,000 pieces of debris, which was not very good in terms of being a responsible spacefaring nation. And They took a lot of heat for that from the various governments of the world. A lot of demarches out of our State Department and other state departments in Europe and so on, saying this was not really a very smart thing to do, because most of this stuff, because of the orbit it was in, roughly 600 kilometers, is going to be up there for decades. And now we have to track it, we have to worry about it, possibly creating other problems for other satellites. So it was interesting, and I'll talk about this vignette in a moment, but the last test that the Chinese did back in, I guess, January last month, they tested their anti-satellite system, but they tested it against a ballistic missile. They did not test it against an orbiting system, so they did not have a debris problem. It was hit the ballistic missile in space, so it was really the same type of test, but all that debris then came back into the atmosphere. And it was also interesting because the Chinese put out a press release, which I've not seen them do, but they basically said, we just conducted a missile defense test. It was all conducted within the nation of China, and it was not an effect on any other nation. And I think that was probably because of all the negative press and the negative reaction they got from creating this big debris field a couple of years ago with their ASAT test. So that's just one vignette in terms of what folks focus on at Vandenberg, at JFCC Space, in terms of managing and monitoring this environment that we utilize and that we rely on. The second vignette is the SC-19, the Chinese ASAT, and again, just to show you what the folks there are doing and what they are responsible for. Really, it was the responsibility of the Joint Space Operations Center at Vandenberg to assess what this mission was for the Chinese. Was it a threat to any of our systems? When it launched, what was it doing? And then provide that assessment up to my boss and then on up to the Secretary of Defense. And it was truly a great effort by the entire community. We had a host of intelligence indicators that gave us a very good assessment of what this system was and when it was going to launch. So we're able to focus a lot of our assets on that particular location, the launch site. It was a brand new launch site for the Chinese, a place called Korla. They had never launched their SC-19, their ASAT carrier, out of that location, so we had some work to do there to sort out what was going on there and why are they out there. But at the end of the day, we had excellent telemetry, we had excellent overhead imagery, we had excellent information that allowed us, number one, to know what was going on, and number two, to then in real time assess the mission and determine whether it was successful or not. It was interesting too that I had a chart that showed our overhead IR capability. We've got a host of different systems on orbit that provide us very precise infrared imagery and capability, and 7 or 8 of them, and I can't go into details, but it showed when each one was covering this launch site. And I found it very interesting that there was basically about an hour or 2 window during the day when every one of those IR sensors was looking at that launch site, and that's when they launched. So I said, score. You know, it was so we had very good intelligence, we had very good information, we were able to track their vehicle, we were able to see the intercept, and we were able to provide that assessment in just a few minutes up to the Secretary of Defense and give him the information he needed to then pass on to whoever he needed to talk to. And then the final vignette, if you will, is the North Korean Taepodong-2 launch. A little over a year ago now, got a lot of people excited because, again, North Korea is under sanctions not to launch any long-range missiles, and because of that, they were defying that ban, if you will, and we also didn't know what this thing was. It could certainly be an ICBM, it could be a space launch vehicle, and so, again, relying on our intelligence community to make that assessment, we still didn't know, even when they were preparing to launch, exactly what that flight profile and what that mission was going to be. So we actually had the missile defense systems around Hawaii in the eventuality that some part of this missile came toward Hawaii, and they were cocked and ready to go, if you will. And then we certainly had all of our space surveillance assets observing and looking at this, as well as our intelligence assets, again, to make that assessment of what was going on. One of the challenges, and certainly I'll talk about this a little bit later, is the fact that you've got a host of disparate information coming into this operations center, and we don't do a very good job of bringing that data in, fusing that data, collating that data, and presenting a picture to a commander that he can make a decision with. It's all pieces and parts, it's emails, it's voice comm, it's displays, it's whatever, chat rooms, all trying to bring information into the operations center that somehow has to be fused and then decisions made or assessments made. So that was happening with this Taepodong 2 launch, in that we had overhead IR, we had overhead imagery, we had signals intelligence stuff coming in, we had a contractor, Northrop and Azusa, that had a pretty slick way of taking IR data and processing it that we didn't have operationally. We brought that in to the ops center and flowed all that data in order to ultimately make a real-time assessment on what this missile was going to be doing. It all worked, but like I said, it's not the best way to do business. I often say that we are doing command and control of our space systems in the 21st century with 20th century capability, and frankly, we need to do better than that. But the mission launched. We tracked the first stage. We tracked the second stage. We could see, based on the second stage performance, that they were probably trying to get into space and not be an ICBM. So we were able to make that assessment and provide that up ultimately to the Secretary of Defense. And then we were able to track the third stage and determine that ultimately it was a failure. Even though I've got a wonderful North Korean news clip that talks about the wonderful success of their mission of placing a satellite in space. Should have brought that. It's pretty funny. But again, just great work by the contractor team, the industry team, the military team to bring all this data together. And the third stage doesn't burn very bright, so getting a good IR signature off of that was pretty difficult. And that's really where we did rely on this contractor expertise out at Azusa to really feed us some good raw data that allowed us to determine what was going on. And ultimately, the vehicle actually pinwheeled. The third stage was pinwheeling, so they probably had some sort of control problem on their third stage, and they did not achieve orbit. So those are just 3 vignettes to kind of give you a sense of some of the things from the operational command and control perspective that we worry about as we manage all of these disparate systems across the DoD for our military. In terms of some of the challenges, I think my title was Challenges and Opportunities in the 21st Century. The first one I'll talk about is debris. I think that as space continues to become more populated, as nation states continue to desire to be a spacefaring nation, you look at Iran, their recent celebration of the, I think, overthrow of the Shah or something. They brought out 3 new satellites they said they're going to build and a new rocket they said they're going to launch. All nations, I think, either want to have space capability or want to be able to put things in space. And I would argue that not all those nations are nice actors, if you will. So this creation of debris in orbit, this creation of more stuff in orbit is something that's going to have to be managed. And other than tracking it today, and other than putting in place good practices when you launch things, which the U.S. now does. I mean, we used to throw off explosive bolts when we separated stages and those sorts of things that would stay on orbit for 5 or 10 years. We don't do that stuff anymore. We capture those sorts of things and they burn into the atmosphere. But we will continue to see, in my opinion, increased debris that is potentially going to threaten, especially in the low Earth orbit belt, our systems. And we have to be able to sort out how are we going to manage that. I know, for example, DARPA has some work that they're trying to look at in terms of how do you bring small debris back to Earth? Can you use a ground-based laser to create a plasma effect on the debris and vector that thrust from the plasma and drive it into the atmosphere? I mean, that's kind of DARPA far-out stuff. They should be thinking about that. So sorting out how we manage this whole debris scenario, I think, is going to be challenging. As I said, I believe we generally track down to about 10 centimeters with the systems we have today. But if you go down to 1 to 2 centimeters, which can still be a threat in terms of if it hits a satellite traveling at 17,000 miles an hour, NASA would postulate that the number of those objects is over 100,000. So how do you get your arms around that in terms of making sure that there's a safe environment to operate in space? And for us, on the Air Force side and the U.S. side, certainly our systems are not as good as we would like them to be. One example in terms of our space surveillance network is that we do not have coverage in the southern hemisphere very well. We can track a lot of things in the northern hemisphere. We got sites in Alaska, we got sites in Florida, we got sites in the UK. But we really don't have any sites in the southern hemisphere, and that's somewhat limiting, especially when you think about China as they launch south. We don't see their initial launch vectors. We don't see their initial deployment of their satellites. So we're doing some work with the Australians, hopefully to get some capability down there with some radar systems that would give us better coverage of the southern hemisphere as systems fly over that particular area. We're also planning to launch this summer from Vandenberg the space-based space surveillance system, which is basically a telescope in space that we'll use for tracking space objects. And primarily that will go track objects at the geobelt, the geosynchronous belt where all your communication satellites are, our missile warning satellites are located there. So our intent is to have this telescope on orbit, which will give us much greater capability in terms of accuracy and in terms of timeliness in tracking those objects in the geobelt. Today we rely on primarily ground-based electro-optical telescopes to do that. Morón, Spain, Socorro, New Mexico, different locations around the globe. But they're obviously impacted by weather, they're obviously impacted by atmospherics, and so having a telescope on orbit that will allow us to track around the geobelt is going to be a great capability, and again, that's scheduled to launch here this summer out of Vandenberg Air Force Base. And finally, at least from a military perspective, tracking really isn't just good enough, because ideally we need to know what this object is. What are its characteristics, what are its capabilities, who's the owner, and that gets into the intelligence community, helping us to understand that, as well as it gets into utilizing all the data that we have to characterize these objects. For example, we have a lot of radar data that we use to track systems, but we throw away most of the RF energy that comes into that radar on the front end and just use the track to do the tracking. But we think there's probably some characterization work you could do based on that radar reflected energy from those particular objects that maybe we're not extracting from the front end of that radar. So that's something we're looking at. We've got our huge telescope out at Maui, the top of Haleakala, that we use for space surveillance. They're doing a lot of good work in terms of optical characterization, looking at glint patterns and different things like that that may allow us to better characterize what an object is versus just track an object. So the ability to characterize, I think, is the next step we're going to have to go to understand exactly what these particular objects are, and we have some work to do there. I talked a little bit about data fusion. I think trying to pull all these disparate pieces of data together and properly displaying them is a challenge. I was just out at Al Udeid in Qatar, which is where we have our Air Operations Center for executing operations in Afghanistan and Iraq. And one of the things they said they really need is what we would call a user-defined operational picture, or a UDOP. It's a pretty common term in the military, but it's really a system that allows you to pull whatever data you want to pull and display it however you want to pull, display it and fuse it however you want to fuse it. And we don't have that today. So building those type of systems that bring all these disparate pieces of data, whether it's SIGINT, whether it's imagery, whether it's IR, whether it's raw intelligence, who knows, we have to have systems that allow us to pull all that together and display that data effectively. Another issue that we're finding, the government acquisition system, frankly, is not very agile. And as we move into more of these command and control systems and these IT systems, that government acquisition system is not designed to be very responsive. So even though we know exactly what we'd like to be able to do with our command and control system up at Vandenberg, it's taken us years to get an acquisition system that allows us to put capability in rapidly. So we're going through the machinations of trying to change the system to allow us to do very rapid acquisition, very rapid deployment of systems. But then you get into all the information assurance Nazis that are out there that say you can't put this thing on the system until you've validated that it won't open a port and those sorts of things. And even though you may deliver something in 6 months in terms of a capability, the information assurance piece of that and certification may take 9 months. So somehow we've got to get our arms around how we operate in this IT command and control world in a very rapid fashion and get the systems in there versus the standard DoD, Department of Defense way of acquiring things, which is based on preliminary design reviews, critical design reviews, 6 months from now, 2 years from now, and 5 years from now you get a system, maybe. So that's one of the things that we're really trying to struggle with, and we were back at OSD in the Pentagon before Christmas talking to them about how we can work the processes better to allow rapid acquisition of those capabilities. I like to say that space is a congested environment. We've talked about that, but also that space is a contested environment. Over the last 3 months, we've seen the Iranians jamming the Voice of America. Anytime that the Voice of America carries the Persian News Network, they go up and jam it. So right there you have someone that's denying access to a capability that we would like to put into the nation of Iran. If you go back to Operation Iraqi Freedom on the initial combat activities there, the Iraqis placed a host of GPS jammers around Baghdad, recognizing that we would probably be relying on GPS guidance for our systems, which in fact we did. And that was now almost 10 years ago that they were doing this. And there are a host of GPS jammers out there today. You can go buy them on the internet. And so for a nation's military that relies on GPS to operate, how do you then determine the best way to operate when someone is trying to jam that signal? What are your alternatives? Or how do you make the system better so you can operate through that environment? And certainly we're attacking that on a couple fronts. Our new generation of GPS satellites will have higher powered spot beams, which will allow us to focus energy on a particular area and ideally operate through a jamming environment. They have anti-spoof capability that we've built into those systems. So from a system perspective, we're certainly working very hard to make sure, for example, that GPS is there when we need it as the nation's military. But I would offer that in this potential future contested environment, should we get into a conflict, it's very easy to put a bunch of RF energy up and jam systems, whether it's SATCOM, whether it's GPS, whether it's satellite downlinks, or whatever the case may be. So we're going to have to sort out how do we deal in that type of environment when we are up against an adversary who wants to make sure he denies us what I would offer is our asymmetric advantage to execute military operations, and that's our reliance on space systems. The whole intelligence world, I think, is going to be a challenge for us, just because I would offer that there's more and more intelligence data coming in, but we have not yet determined how do you process all of that, how do you exploit that, and how do you get that to the decision makers to use effectively. A great example is the latest space-based infrared systems that we've launched, SBIRS. It's our primary missile warning system, which tracks infrared signatures from ICBMs, from SCUDs, from those sorts of things. And in the past, the older systems was essentially an IR sensor that scanned every 10 seconds, and you would get a little dot on your screen that showed effectively the flight of the ICBM as it launched, but it was just a series of dots that you would watch. But this new system is a very effective IR sensor. It's basically a staring sensor, and you basically get the picture, the IR picture of various IR events that are going on. That's great for seeing a missile launch. It's great for missile warning. We do that very effectively, but because now of the fact that it's essentially a staring sensor and it's very efficient and can detect very low IR events, you really have an intelligence system. You essentially have an IR image that's persistent over a particular location. But how do we exploit that data? How do you use that data? How do you get that data into a fusion system, if you will, that brings in other all-source intelligence that, again, that presents that operational picture that a commander or someone would have to utilize that. So again, we're working through some of those issues, but I would offer that there's a lot of data now coming in, terabytes of data coming in from space, whether it's imagery systems, IR systems, whatever, and getting our arms around how you manage, and SIGINT systems, how you manage all that is going to be a challenge, and how you present that and fuse that data. Another challenging area I would offer is just integrating all these capabilities, and one that I would focus on that's gotten certainly some press here in the last few months is the whole issue of cyber protection, cyber exploitation. You've all, I'm sure, read about Google and the cyber attacks and pulling out of China. The Department of Defense is trying to stand up a U.S. Cyber Command that really utilizes a lot of the guts of NSA, the National Security Agency, to do that. A lot of political questions from Congress about what does that really mean, what are they really going to do. But as you think about the whole cyber activity, whether it's protecting your systems, whether it's exploiting other people's systems, whether it's pulling data out of other people's systems, whatever the case may be, I would offer that there's a fair amount of intersection between what we do in the space world, because really what we do is about information. if you will, getting information from a sensor to the person that needs it at the right time, at the right place, with the right data. And the similarities between the cyber world, which is making sure information flows, information is protected. So determining how we put all that together to be very effective to conduct operations from a military perspective is something that we're starting to think about. We just executed what we called a non-kinetic warfighter event out at Nellis Air Force Base back before Christmas, where we actually used some of our space systems to gain access to a virtual private network, and then we used some of our cyber systems once we got into that virtual private network to do some things in that network. And that was the first time we had tried to operationally put some of that capability together and determine how we could utilize some of that capability. So thinking about how we put all this together from a space and a cyber perspective, I think is going to be very interesting over the next few years. And finally, I think one of the challenges, and certainly in my mind an opportunity, is what we would call operationally responsive space. You can call it, getting to space effectively, more responsive, more rapid. But a lot of good work going on. There's folks down at Kirtland Air Force Base that are doing a lot of work on small satellites, very rapidly assembled and responsive systems that can meet a need. There's work going on small boosters. We're very excited to have the SpaceX company preparing to launch their Falcon 9 down at Cape Canaveral. They just delivered all the hardware in the last couple weeks for the Falcon 9, and we're shooting for a launch of that rocket in March. Really the first full commercial rocket system that's been out there and been successful. They've had some successful launches on their Falcon 1. This is a Falcon 9 engines, a whole different variant. And we're hoping for great success from them because we believe that certainly the commercial environment can provide some great capability and hopefully at a much cheaper cost than what we've been able to do on the government side over the last couple of decades. So we're looking forward to a successful launch there with the Falcon 9 system and the SpaceX Corporation. So those are just some of the challenges, and I would offer certainly some opportunities there in terms of addressing those challenges that we see out at 14th Air Force and JOCC Space. And so I hope that when you see a rocket launch out of Vandenberg in the future, you recall that we do more than just rocket launches there. We have the responsibility for managing all of our DoD space systems around the globe. And the folks there are doing a great job for you and for our nation. So thank you very much.
Thank you, General James. Dan Burnham is the retired CEO and chairman of the Raytheon Company. He joined the company in 1998 and retired as CEO in July 2003 and chairman in January 2004. Mr. Burnham joined Raytheon from Allied Signal, where he had most recently served as vice chairman and member of the board of directors. He's also been a director of a number of other companies and has recently moved to Santa Barbara. I wonder if you can start off by sharing some of your background in the aerospace industry and some of the challenges and opportunities that you see.
I'd be happy to. By the way, I'm also chairman of the board of the UCSB Foundation, which means I'm always in the search for money. Now, that generally clears out rooms pretty quickly. At Raytheon, we had about a $5 billion space business, sensors and tactical surveillance and missile tracking and environmental monitoring. And at Honeywell, which was Allied Signal when I was there, we were on every human space mission that ever happened. We had thousands and thousands of devices, from gyros to ECS, environmental control systems, to avionics, to data control. So at some level, we were at both ends of it. We were in the whole data fusion sensor business, but we're also in the actuator business and the generator business and all the bits and pieces that make all these things work. Very often, space is thought of as rockets, sensors, but people forget all the little devices that are on those, and most of the space business is that stuff. So that's sort of my background in it, and I don't know, this is a panel, so I don't really have prepared comments, but let me just, as long as I got it, why don't I continue? Let you rest. Sure. Okay. Let me sort of give you some views about the space business. I am a business person. I, unlike most of you, am not an engineer, but we made a lot of money in the space business over a lot of years, and I'll share with you some thoughts. By the way, occasionally we lost a lot of money, and perhaps that's a more useful lesson. So we did a lot of business with NASA and a lot of business with DOD. Now, NASA's been really going through the throes of hell the last many, many, many years. I think the basic reason that they have is that NASA has been unsuccessful in making a case as to why people should be investing in space. They are not the ones that are capable of making the case. The people who are making the case are you, are the people who depend on the space business. It's been proven over and over again that NASA can't sell it. Now, having said that, they were at least able to sell that with the cancellation of the shuttle, that they were still able to restore the budget. So their $19 billion this year is going to go to $21 billion, even though $3 billion is being taken out of the shuttle. So there's real opportunity there. But as I say, it's up to all of us to continue to sell the reason for space. And I think the argument that it's part of the human condition to explore is not a compelling argument. We could argue that, but that's at least not my view of it. Having said that, there's going to be a lot of new business out there for all of you. And that's just terrific. But now let me talk about sort of a view of space. It's an interesting fusion of innovation. I mean, all the wonderful technology that we need. It's that plus a very conservative, risk-averse world. It's both of those at the same time. Innovation, wild and crazy thoughts. Let's dream, let's dream, let's dream, and don't ever screw up. I mean, this is a fascinating thing. If we can ever make that Venn diagram completely come together, it's like inventing fusion or something. So what are the skill sets that you need to be successful in the space business? In addition to the skill set that you already bring, I'm presuming that you've got the technical skill set already. The technical skill set is just the ticket to the game, that all your combined years of experience are wonderful. They allow you to enter the game. That's it. They don't give you the odds of winning. Only occasionally does the technical eureka allow you to control the game and make money. But the number of examples of that are too few to even mention. I can't think of a one personally. So the secret to making money is in the much more prosaic, boring, dull world of program management. And yet, program management is not taught in hardly any university. It's assumed that you'll pick it up. It's sort of like saying for all of you electrical engineers in the room, well, you just pick it up. Get your electrician license and you'll figure out all the rest of it as time goes on. Well, it's a lot more complicated than that. But to win in the space business, and I win in my context here means to make money. It's on schedule and it's on cost and it's to have the data that permits you to do it. And yet you're surrounded by people who are fundamentally optimistic, who believe they can win, can say, yes, you're right, I'm only 6 months into it and I'm already 6 months late, but that's okay. I'll make up for it because of this and this and this and this, and they believe it when they're saying it, and you can get caught up in their enthusiasm, and 6 months later they're now, which is 12 months, they're now 12 months late. And this just goes on and on and on. That's the nature of the beast. There are skills to learn to control it. But it just doesn't happen intuitively and from experience. You have to get trained in it, and there's ways of doing it. Should I continue? I don't know. Are you okay with it so far, Larry?
Yeah.
I mean, what did I say you don't agree with?
You're good. But we do train people in the military to do program management.
Yes, you do. And, right. You're right. Yes. On what basis will we judge the success is another question.
We blame the contractor.
That's right. I just, I was brought into the DOD recently by a secretary, I won't say who. No, because I shouldn't. It was a, private kind of thing. And said, come in and tell us what we need to do to fix our programs, because so many of them are so screwed up. It was not the Air Force. I should say that. It was not the Air Force. But, I think these things are generally true. The secretary said, my absolute priority is this. He said systems engineering, but that's okay. We talked to every PEO, Program Executive Office, the 1 and 2 stars, sometimes colonels or Navy captains. We talked to about 15 of them to ask them, what's wrong with the system? If you were God, what would you do? How would you change it? And then we asked the one with the most responsibility. I must have had $8 billion of procurement acquisition responsibility. And we said, we understand the Secretary's highest priority is systems engineering. He said, it is? I've never heard that before. So this need for clarity and flow down, and that was more of a vignette than anything else, but for you to have an absolute clear understanding of what the requirements are. And it's so easy for all of us on the contracting side to say, yeah, I got it, I understand, that's right, fine, I'll write it up, whatever you say, that's great. Because we want to win the contract. We write it up the way we thought it was understood, and we win the contract, and we find out, well, that's not really what we meant. And besides, the person who was talking to us didn't know what the heck he needed. And so, but we were so aggressive or so desirous of winning the contract, we didn't take the time to find out the requirements. And in the absence of that, you're going to lose a lot of money on these contracts. You just are. It'd be interesting, I didn't do a survey because I don't know, what percentage of space-based contracts, other than fixed price, other than cost plus, do people lose money on? It's a big number because of that problem. It's sort of another assertion I would make is you have to have absolute transparency. The program manager on the DoD side or on the NASA side and your program manager have to speak very openly to one another. They will say that they do it, and maybe they believe it, but you've got to make sure it happens. Just your people saying it's happening is no guarantee that it's happening. And in the absence of it, there's going to be a major problem. Now, I say this not because of any books I've read. It's because you learn more by your failures than you do by your wins. And I can't tell you how passionate I am about all the things I just said. You might guess why I am, right? Why don't I stop there on that subject, because I have other things, but see where this goes.
Okay. A question to both of you, maybe General James, you could field this first. The White House announced within the past couple of weeks that NASA was to privatize most of space transport and get out of the business of running the rockets, and wanted to understand what impacts you saw for your own organization.
Well, certainly, I think we're all still sorting through exactly what the programs NASA will move forward with will be, but one of the primary concerns we have is the industrial base. If NASA gets out of the Ares business, which they've been directed to do, their large follow-on to the shuttle, as you look at the rocket providers, the large solid propulsion providers in this nation, they're not that many. And if you take out the NASA piece of that business and they move to just doing the R&D type of stuff, which I think is what the guidance is for them in terms of future propulsion, we certainly have an industrial base concern from a DoD perspective, and make sure we maintain that industrial base, not just the solid producers, but the second and third tier suppliers that are down there that we need to be concerned about. On the commercial flip side, again, I think this is an interesting time. Understanding the commercial space launch business, as you look at providers like Burt Rutan and White Knight, I realize that's suborbital, but you've got SpaceX that I've mentioned, you've got Orbital Sciences Corporation with their Minotaur and those sorts of things that are trying to create that capability. We hope they are successful, but to get a man-rated vehicle is going to be challenging, and so we'll see where that goes.
You know, the analog to me a little bit is back when the Army said the trick here is for us to integrate all these systems, and we've lost our capability of integrating them because they've allowed all their acquisition professionals to leave. And so therefore, we will get Boeing to do the work there. I've solved that problem. Thank God I've got the world's largest system integrator, and now the problem's fixed. Going to commercial space does not solve space launch problems. It allows people to say, well, we have a different strategy, we will allow them to do it. That is wonderful. I'm a supporter of that. But it begs the question of how do we assure that they are paying attention to such things as the supplier base? I remember right in the heat of the International Space Station, which is a fabulous discussion unto itself. We had 19 subsystems, more by far than any other company. I got a call from Dan Golden saying, I want to congratulate you because single-handedly, and because of you, he meant our company, because of what you're doing, we are going to be billions over and years late. I said, what are you talking about? Found out that there was this one critical part. I've even forgotten now what the part was. It was made in Indiana. So I find out who's holding up the whole world here. And I call the CEO, is the way I said, I want to talk to the CEO. And, but the person who answered, I heard a lot of machinery in the background, said, the CEO? Yeah, you know, the boss. Okay, Joe, there's somebody here for you. So Joe comes. I said, hello, sir, I just got a call from Dan Golden, and he told me that because of me, but it's really because of you, the whole, you know, technology base of the United States is about to fall apart. And I said, we need that part. And you got to crank up, you got to get going, and you got to put more people. He said, I've got all 4 people on it. And there was nobody else. There was nobody else. Now, giving that to a commercial person doesn't solve that problem. It just doesn't. So it comes down to the nuts and bolts of it all is what's going to make this work. And so there you go.
Okay. I want to open it to questions from the audience. How are space terrorists or bad actors going to impact space programs?
Yeah. Well, the first question, I think, in the near term, everything I see about space tourism is pretty much suborbital. You know, that's what the white knight is and those sorts of things. I mean, getting to orbit is a whole different equation, if you will. So at the suborbital levels, you're generally not too concerned about it, just because there the drag brings most stuff in pretty quick, and you don't have to worry as much about the debris. I would phrase your second question about really non-responsible space actors, if you will, and can they screw things up? Yeah, I mean, I think the great example is China with their ASAT and creating thousands of pieces of debris. If the Iranians launch something and it blows up and they really haven't, you know, put in the right mitigation, and you now create another debris field. They do it on purpose. Yeah, I mean, if they did it on purpose, yeah, I mean, certainly that can create problems. But, you know, I would offer that that's a lot of money and resources to put into something like that. I would think they would really be more tactical, and just like the Chinese try to develop an ASAT system, then you control it, then you can go after a particular system if you want to. Whereas debris is pretty much doesn't care where it goes. I mean, it's hard to direct it, if you will, to be effective unless you just want to create havoc. But it takes a lot of debris to create havoc. So I'm not as concerned about that as I am just about the gradual increase of debris over time by people who aren't acting responsibly. And you can start to get cascading effects. I mean, if you get enough collisions, then one collision begats more collisions. And then you suddenly get into this whole scenario where you get a cascading effect. And some people look at that, and there's possibilities of that.
The question is, are there pressing timelines for Congress to move NASA programs forward?
You dealt with Congress, I'll let you talk.
No, I guess would be the answer. You know, they don't work like we work. I mean, it's a whole different deal. It's all politics. frankly, I am hoping that there's going to be some hard choices made. I think the cancellation of the shuttle, one could argue was a hard choice. I argue it was not. It was an obvious choice. They had no choice but to cancel it. And they've got to keep business in all the congressional districts that are supported by space. This is a very slow-moving deal. So there's not going to be big pushes up or down. In fact, the general tendency is a little bit up. But until and when there's some commission that has the equivalent of BRAC authority to deal with the deficit, it's just going to be stasis, in my view.
The question is, why isn't there an impetus to, I guess, incentivize technologies that make it cheaper to get into space?
And I'll speak to this, but certainly Dan could too, I'm sure. We are trying to invest at some level, as you said. I mean, the military has been investing in some technologies. DARPA is out there. We have conversations with them about what can they invest in, and launch is one of those things. The Air Force Research Lab out at Kirtland has been doing some work in technologies. One of the things we've looked at is, like the hybrid vehicle. But the flip side of that is, it's a tough budget environment. I think we lost this.
Yeah.
But, here we go. It's a tough budget environment, and the R&D piece of that, just it's tough to get traction sometimes. I mean, I am a great proponent of trying to invest in launch technologies that drive the cost down, because I agree with you. I mean, that is the barrier to getting into space. If we can cut it by 100-fold or 10-fold or whatever, you open up a lot of opportunities, and ultimately you open up the commercial market much more than it is today. But there's not a lot of R&D dollars to go around, and from a DoD perspective, it's not a threat that you're facing today. It's not an existential threat to the U.S. And so trying to get enough dollars to create momentum is difficult. But,
in the absence of almost an obsessively dedicated senior official towards that, it's not likely to happen. On the other hand, the system does respond to occasionally kind of cool stuff. Okay, is it Musk? Is that his name?
Elon, yeah, Elon Musk.
I mean, this guy can actually make something happen. Washington's going to know it. You will find congressmen and senators who kind of get excited about it, who then start calling Larry to say, why aren't you funding this? So, I mean, I think, I don't want it to make it sound like I am cynical. I perhaps am a bit, but in this case, if there is somebody with the kind of guts and resources that he has and can actually do it, and he can find somebody in Congress that's going to get excited about it, and I think he could, then the pressure is applied to an inherently conservative system. But it's going to take real pressure to do it.
Yeah, Henry. The question is, are sensor... Okay. First question is, are the sensor integration companies in this area slowing down the sensor manufacturers in this area?
Well, the way I would respond to that is, and it kind of goes back to my remarks, that we're getting a lot of great sensors, at least on the orbital side of things, that we still have yet to figure out how to exploit all the data, frankly, and how to then integrate that into the systems that you need to integrate. Because ultimately it has to get to a person who has to make a decision. I mean, that's why you have sensors. So yeah, I would say that is lagging. I'm not sure that's going to stop us from building these exquisite sensors. I mean, we're going to continue to launch the space-based infrared system. We're going to continue to have FLIR systems. We're going to continue to launch the next generation electro-optical, intelligence systems. We're still looking at radar systems, but what we call the TPED, the tasking, processing, exploitation, and dissemination, is definitely behind. And folks like the NGA, National Geospatial Agency, are working some of that. But we definitely could use some smarter ideas on how you handle these terabytes of data in an effective manner.
By the way, Henry, sort of almost implicit in your question is all these great people are out there doing great sensors, they're meeting all the goals, and it's not working for some reason other than the sensors. And for a company that made a lot of sensors, we should simply accept that premise and move on. But it's not always that case. Some of these sensors are, hello, are,
Sorry,
are-
it takes 4 hours to get from Santa Monica here, and Google said 2.
well, I took care of Northrop for you. How's that? No. And, but the fact is that sensors themselves are incredibly complicated devices, and there's a tremendous amount of technology in them, and they don't always come off on time and on budget. It's a very, very complicated, but let me ask a question, or because Henry made me think about it. Why Santa Barbara? Why California? Why should this be of interest to us? Why is this business going to come here besides the reality of Vandenberg, which is wonderful? And here's just something to think about. We all know the following names, by heart: Hewlett-Packard, Google, Intel, Cisco, and many of you know Sand Hill. Okay, you all know basically where they are. Okay, now there's some people here that are within shouting age of my age, so you'll remember some of these names: Prime, Digital, Wang, Data General. Right. What does that second group all have in common? They're gone. What else do they have
East
in common?
Coast. East Coast.
Well, more than the East Coast. Oh no, there's a lot of really smart people here.
Corridor 28.
Think about this. MIT. No, that's a joke. It's a joke. Raytheon got started with MIT too, and it worked out. But there is really an important cultural advantage that we have here in California, and I'd like to say uniquely Santa Barbara, and that is we're not hierarchical and fundamentally bureaucratic. The East Coast is. I mean, I know what I'm talking about. Here we're more casual, more independent. We ask ourselves, our engineers, what can I do to make a mark? And then there's VC support. Admittedly, it's a little tougher right at the moment. Stanford encouraged wide participation of all these little companies up in Silicon Valley. So you had all these little firms who had to trust one another because none of them had enough resources to do it on their own in the beginning. Well, that kind of describes Santa Barbara. We've got a lot of small companies here that rely on one another, or should. And so I guess one of the themes I'd like to try to convince all of you who are here in our community is to team even more effectively than you do, because you don't have the size and substance to take it all on yourself. That is, after all, the source of Silicon Valley's wealth, I would argue, their openness, their collaboration, their spirit of adventure, and we have that here. So I think we have the technology and we have the basic spirit. Whether we have the discipline to actually execute things is, to me, a bigger question. So that's it. Nobody asked the question, but that's an answer.
No, thank you. Real quickly, I'd like to introduce Dave Maston, CEO of Maston Space Systems, and I'm wondering if
Damn Burnham.
if you might be able to just give us some background about your company and what you've done since, including winning the X Prize Lunar Lander Challenge.
Sure. So basically, in 2004, I started up Maston Space Systems with the idea of completely changing the way aerospace is done and the way aerospace is thought of. The primary goal is to make all launch operations something that's done operationally and done more like aircraft flying than launching big missiles. What we've done towards that was started off with something small, just take a very small concept, prove it out, and it doesn't have the performance to really go anywhere. It doesn't have the capacity to take anything anywhere. But what it did prove is that we can launch and fly a rocket-powered vehicle with only 3 people, and we can do that multiple times a day and do it safely. We built on that concept, and we got to the point where last year we were able to actually have a vehicle that was able to fly the Northrop Grumman Lunar Lander Challenge, which is basically take off, go up 50 meters, translate over 50 meters, come back down and land, and then turn around, refuel it, and do it all again within a span of about 2 hours. So that's the real brief nutshell.
Okay. I'd like to come back to the point then that Dan raised, and maybe turn the question to General James. What are your thoughts about how our local area can strengthen its ability to support space technology and operations? Is there anything on the level of organizations like this, or startup companies, or universities, or something that the Air Force can do to kind of harness synergy from all these groups?
Well, that's a tough question, frankly. I go back to one of the comments Dan made is understanding what the needs are, or the requirements are out there, and then trying to determine in some kind of local fashion what are the niche areas that the companies here in Santa Barbara or this area can attack, whether it's sensors, whether it's displays, whether it's fusion, information fusion, whatever the case may be. I mean, understanding the needs that are out there and then sorting out, okay, what capabilities are here that can go attack those requirements would be where I would start. I've tried to, hit some of those today. But I would offer, I kind of use, with my folks, I use the iPhone analogy. I mean, what we would like to have is the ability, for example, to fly the GPS constellation on an iPhone. I mean, that's kind of where we think we need to head, and that's somewhat hyperbole, but in reality, I mean, those are the kind of things we are thinking about in terms of at least information technology systems, command and control systems, et cetera, et cetera. How do we move forward in that arena? And that's bringing all this data together, bringing all these sensors together, bringing all this together, and I think there's capacity here to think about that and come up with innovative solutions on how we do that.
Okay, thanks. Yes. I'm wondering if we question for Dave Maston. I'm wondering if you could talk about the barriers to entry for a startup like yours. I think a lot of us might be familiar with startups of an internet or software nature. Maybe you can talk about, the barriers to entry for starting a rocket launch company and how that might be different than the typical startup.
Well, some of the barriers of entry. The first barrier of entry is actually is strictly investment. Not more than a few years ago, if you went to any investment, anybody who might be interested in investing or whatever, and said, "Hey, I've got this great idea for a space company," you can wait about half an hour before they'll stop laughing. That has changed a little bit. We've seen a number of space companies being able to start up, some of them actually being funded by other than their own pockets. The other big challenge right now is regulatory. And it isn't the regulations about launching, it's the regulations about who you can talk to about your technology. We had a problem. I really wanted to bring on a very knowledgeable person to help out with our company. Unfortunately, he's Canadian. Now, that shouldn't be a problem, but we have these things. We have the International Traffic and Arms Regulations, which basically said, well, yeah, you can talk to him after you go through the State Department and have your lawyers fill out lots of paperwork and spend a little bit of money. Small business with very little capital, that's not going to happen. I can't afford to do that. So those are pretty much the two basic barriers to entry. You basically have to have a whole lot of money to start off on your own, and you have to be able to pay the lawyers.
Okay. Yes. The question for all three panelists is: Are you concerned about the future of the aerospace workforce?
Well, certainly, I think if you go to any of the industry meetings that we have, I mean, that is a concern. There's a whole effort to look at the scientific, mathematics, engineering kind of effort and get people interested in high school, get people interested in aerospace, if you will. But yes, it just seems that as you look at the graduating rates for American kids in the engineering sciences and the sciences in general, it's lower than it needs to be. So we are concerned. There are a lot of efforts, both industrial, in the military, and the government, to bring more of those people in, get them excited, work at the high school levels, and do those sorts of things. I don't have an answer in terms of where we are, but we're certainly trying to address it.
Look, I think it's a big deal problem. But there are glimmers. Dos Pueblos High School, how many of you know DPHS? They have the coolest thing there. They've got this young physicist, mechanical engineer. I think he's undergraduate physics, graduate mechanical engineer. Mere complicated name. And he decided he wanted to go back to teaching. He just loves teaching. And he's created this engineering academy. I went over there. He has a waiting list of kids to get in. And the kids who are waiting to get in, you know, the captain of the football team, the head cheerleader, it's cool. There's an excitement there because they do really neat stuff. And so with initiative and creativity, this stuff can happen. By the way, Raytheon is supporting it because I'm trying to get Raytheon to have 100 of these schools around. We got to turn engineering to be cool. Remember how it was in the 60s because of Sputnik? It was cool. So many of you went to school in the 60s. It was cool. Well, it kind of got less cool. Now it's maybe a little cool. So that's one. Second, DOD can make a difference tomorrow if it wanted to. All it has to do is to say for every contract greater than $50 million, that you, as the contractor, have to describe the efforts that you are doing or intend to do to support math and science teaching in your local communities. You know, and that's a requirement, and it's going to become a differentiator. Just like that. We would have, think of all the retired engineers who would love to do it. They just need some help, some push, some structure. So there are ways to do it, but it's going to take that kind of a push. It's not going to just happen by, you know, hoping.
Actually, my biggest concern isn't the number of people coming out. It's the large disparity in that most of the people coming out look like me, white and male. There is very little diversity in aerospace, and that's a really big concern. Things are starting to improve. It's gotten much better over the past several years, but we're still way behind on actually getting somebody other than white men in the business.
Recruit from UCSB, we have the highest percentage of, we don't call them minority students anymore. It's, there's some PC term for it. Yeah. Huh?
Cultural diversity.
Oh, yeah, but I mean, we have the highest percentage in the whole UC system. We have the top engineering schools, so come on over.
Great. Yvonne?
Look, I think
Let me just interrupt with the question. The question is what is the difference for success? Is it program management training, or is it something, a company like SpaceX that has very flat management structure?
I think SpaceX may have some magic angel dust somewhere that they can figure it out. But you really have to sort of rely on what is proven to be true over and over and over again. A huge percentage of programs get screwed up, and the acquirers spend all of their time fixing screwed up programs. The less that you screw up programs for them, the more likely they're going to want you to be their next supplier. Now, for something like SpaceX, which is cool and neat and highly visible in a whole different direction, is great for them. And maybe some of you could do that. I'm talking about the 95% of the procurements that are going to happen. And there you've got to have process discipline. But not process discipline in the absence of innovation and cleverness and creativity and intelligence. All those things you got to have. The differentiator can be effective program management.
So how do you achieve
that? Well, how do you achieve it?
How do you achieve effective program management?
Can I step in for a moment?
Please do.
Having a probably flatter organization than even Elon Musk and SpaceX, the biggest thing here is company size. SpaceX is still a small enough company where they can be very selective in who they hire. So, and likewise with Mass and Space Systems, we are very selective about who we hire, and what we're looking for is somebody who is going to get the job done. When you get to a larger company, there becomes a point where you're large enough that you cannot afford that selectivity anymore. Also, it's hard to attract the best when you can't give them a reasonable chance of cashing out with stock options at some point in the future. That's actually a very important part of the model if you're looking for truly the best and the brightest. Smaller, newer companies can do that. So I mean, a lot of that is you're just going to have to deal with the fact that as organizations grow to a larger size, you're going to have more and more of the problems of somebody who's ineffective in a role.
Great. Sure.
If you look at all, it's absolutely key.
How do you find the right type of leadership to build successful space operation or startup?
For a startup, you be the right type of leadership. That's really all there is to it. It's either you are the right type of leadership, or your business, or you go out of business very quickly.
Any other thoughts?
Well, for startup, I can't respond to that so much. I mean, what's great leadership? I mean, it's first of all making it clear to people what's important. And a great space company is going to be true for a lot of great technology-based companies, which is that we cherish innovation and we cherish performance. Performance means you do what you're supposed to do on time and in budget. And we're going to provide you the training and the support and the structure around you to help you do that. And then to define the supporting systems that see that gets done. You can't just say it. You got to provide the training and the support systems to make it happen.
I mean, you know, you're kind of asking fundamental questions of leadership here that people have tried to define for a long time. But I'll use an example. As I was the director of SIGINT at the NRO, and the contractor, which I can't name, but which made those systems, was very effective. And I would offer a couple of things. Number one, it was a mission that people were proud to be a part of and they knew was extremely important to our nation. And that provides, I think, the motivation to bring out the best and brightest. So part of it is the mission and what you're trying to accomplish, and people all getting on board with understanding that this is important and I'm going to do my very best. And then the leadership has to bring that into focus, I believe, and then stay on top of all those things that are basic blocking and tackling of program management, whether it's requirements changes, system level changes, how do you manage all that? How does everyone know down to the guy turning the wrench that this is where we're headed today? And having the leadership and the tenacity to make sure all of that happens. And then, at least for us in the SIGINT world, building those very complex systems, part of it was we had the processes pretty well baked in because we had been doing that for quite a few years. We made incremental changes as we needed to, but we understood how to build these systems even though they were very complex, and we could execute effectively, and we had a lot of longevity in the team. So all of that, that's one vignette, I think, but it kind of gives you a good example, I think, of a very successful program, very complex systems, and yet they were executed very well.
I'll just give you one little vignette. Raytheon probably has more programs at any time than anybody because we have a lot of small ones, maybe 8,000 programs going at a time. And so how do you drive that sort of thing? Well, you know, deep in my soul is the belief that the most profound motivators are not stock options. It's pride and guilt. It's true. I remember...
That's great after you've hired them.
That's right. I remember I got a call, and the head of acquisition for the Navy wanted to see me, came to my office, and he showed me a chart. It was a simple two-dimensional chart, and it had all these little dots on it. And you wanted to be either in the middle or in New England, so to speak, on this map, which meant you were ahead of in terms of time and under in budget. And he must have had 100 different little dots on it. And color-coded with, at the time, the Raytheon ones were in, let's say green. Well, the green ones were mostly in Arizona, which is not where you want to be in this thing. And there was a vector pointing, and I had only just come with the company, and it was fascinating. That chart changed the nature of the company, because that became a requirement at every major review to talk about what programs are in the Arizona area and what's the vector. And we found with training and support that the weight of it started to move sharply up through Ohio and into Buffalo and like that. And now some of the, so it's pride and it's guilt and it's talking and it's reinforcing. And I don't think money is, frankly, all that big a deal. I mean, it is, sure it is for some important segment of people, and you can't, you know, be unfair or anything. But it's that drives people mostly, in my view.
Great. Yeah, I'm sorry, here. It's a question for General James. Do you have a wish list from companies in this area?
A couple things. Certainly from the range perspective, the Western Range, where we operate those systems that do the launch. I mean, we need a lot of work there in terms of upgrading those systems. Those systems, many of them in terms of the radars and the tracking systems and the infrastructure were all put in the 60s and 70s. So a lot of that needs to be improved and sorted out. How do we bring all this, again, as I would say, the 21st century capability? We're looking at a lot of options. GPS metric tracking, for example, where we track the booster with the GPS transponder on board the vehicle versus having radar skin track. Allows us to get rid of the radars. Can we move to that sort of environment? Autonomous flight destruct systems, which would allow us to, again, not necessarily have the data that we have to have coming down, but you have onboard flight destruct systems. So just moving the range itself into the 21st century with some of those capabilities, I think, is very important from a purely Vandenberg perspective. And then I'll just go back to what I've already said in terms of just the command and control systems, building better command and control management, data infrastructure, all those things that we need to do, because we're still doing stuff with manual PowerPoint entries. You know, we got to get away from that. So those are the two key areas I would focus on.
The question is, does the truthfulness in evaluating space programs that NASA performs in terms of lessons learned, is that going to carry over with increased privatization for space operations?
Look at this private.
I sort of heard something in there, and maybe I heard it wrong. Sort of that in the private sector we don't have that yet. Did I hear that?
I haven't heard of it being rewarded very often.
So one of the big things in any technology business, and especially with the smaller startups that are going on right now, is the taking, you know, if you do something wrong and taking the hit, that's expected, and I won't say it's rewarded, but it's not, you know, you're not going to get fired if you say, oh shoot, I made this mistake. It's a really hard balance to manage correctly, but because you don't want to reward people for making mistakes, but on the other hand, you do want to reward them for coming forward and saying, hey, this is wrong. But basically, you know, within myself, what I've seen from SpaceX, what I've seen from our neighbors, Skilled Composites and XCore out in Mojave, you know, the coming up and saying, hey, you know, I think I messed up my units here, that isn't a bad thing for people, and that's something that does happen. Otherwise we can't make it anywhere. We don't have a product to offer if we, you know, try to hide all of our mistakes.
And I would offer that, I mean, I'll use SpaceX as an example. I mean, I was at their factory in December, spent a half a day there. I talked to Elon about 2 weeks ago about where we are with Falcon 9. I would offer that there's, at least there is a culture of transparency. There is a culture of openness. We're working very closely with them on, you know, their flight termination system. They still haven't got their flight termination system certified. So, you know, they offer that up, you know, so here's where we are, here's what we're doing, and we work with them very closely. So I think there is that culture of transparency that we all have to get to, that I've seen, at least in those commercial companies that we're working with.
Yeah, I think, you know, there's sort of the human animal is at work, and, you know, there's sort of a basic, I don't know, atavistic drive to not tell everybody how you screwed up. I mean, there's something just at work there, you know, and just hope that goes away It's not going to just go away. So it seems to me that included in the solutions are training of all the people, that the longer the problem stays hidden, the bigger the problem is and the more expensive the solution is, to trade best practices, to have lessons learned, and to drive that, talk about it all the time, and to have bosses who are skeptical enough and cognizant enough about human nature to not just take, yeah, boss, everything's fine, as an answer. I mean, I think it's a complicated solution. There is no simple answer,
Yeah.
but it includes all that stuff.
The other thing that we often do is we go out to do a test, and we assume that if we're going out to do a flight test, the assumption is the vehicle is going to fall down out of the air and crash and go boom. So let's go out there and test something, learn something. And when you have the expectation that you're going to go out there and you're going to fly and that things aren't going to go right and it's expected that they're not going to go right, people aren't quite as reticent about admitting mistakes.
I'm sure that's true, but let's take a missile defense test. $150 to $200 million for a test, right? Okay. Do you really want to be the bolt that screws that up? I mean, there's a lot of pressure for don't make any mistakes, and there just is, and because some of these things are just outrageous.
Well, maybe you're not testing early enough in the process
Yeah,
then. Because if it's going to be that expensive.
yeah, right.
Yep, back here. The question is, in light of the shrinking industrial base and the possible reliance on manufacturers that maybe the Defense Department would not want to do business with, how does the Air Force handle that?
Well, I think it's a broader question too, but certainly there is activity at the DoD level to look at what are those second and third tier vendors. Do we have a problem in particular areas that we need to potentially invest in? So those type of assessments and analysis are ongoing at kind of the DoD level, as well as I mentioned earlier, partnering with the aerospace companies and the various folks around the nation that can indeed go into the schools and make a difference in terms of helping motivate people to get into that, offer scholarships in those particular arenas. So it's several different ways of approaching that, none of which each on its own is going to solve it, but I think there's a recognition and some analysis ongoing to at least understand, second tier supplier, if he goes away, he's the only one. Okay, how do we make sure we keep him in business, for example? So that's going on.
Yeah, I think included in the answers is to put the onus where it belongs. Whoever wins that contract had better have a multiplicity of, first of all, to understand the critical supply needs. That is that little four-man shop in Indiana. We didn't even know that we had that. To know that, to define it in the procurement process, and to identify what you're doing to either set up an alternative, getting the skill base yourself, or do something to identify it in the procurement process and put it on a contractor that it's your responsibility to fix it. We're not going to go offshore with that stuff. That's just not going to happen. And it is true that we have a smaller and smaller manufacturing base. And again, it's great for DOD to take a look at it and DOD to worry about it, but that is not going to solve it. It's got to be put at the contractor level. I mean, I actually spent most of my time dealing with commercial aviation. And certainly those guys weren't perfect. But Boeing would not, or let's say Bombardier, which was frankly the best of the bunch, believe it or not, they knew exactly what their major contractors were doing. Exactly. And they made darn sure that you had backup capacity in any one of your critical dimensions. They just made it happen. And it's a relatively small company. They just put those demands out there. So I mean, I think that's really the solution.
Well, there's another aspect of this, and So much that we're losing a certain amount of manufacturing capability is not a big concern to me. I really couldn't care less who pours the steel and gives us sheet and bar. But what I am more concerned about is areas where the United States has a comparative and absolute advantage, that we're losing. For example, the GPS system that we use on our vehicles is built by a company that is not in the United States. I cannot buy an equivalent quality GPS in the United States at all. The reason for this is because spacecraft type GPSs tend to go into other systems, and it's all under ITAR control. And everybody else in the world says, if you've got ITAR on it, we don't want it. So one of the biggest, best GPS manufacturers is here in the United States. They do not do anything except consumer grade GPS. If you want a higher quality system, you go outside the US. So what you can do about that is contact your Congress people and say, hey, get rid of this ITAR thing.
Sure. Henry. The comment was, during World War II, we had an enormous output of technology innovation. What is not happening today, and what can be done to recreate that?
Well, I would go back to the crisis comment. I mean, you basically had a nation in crisis that was totally focused on executing World War II. I mean, that's what all the factories were worried about. That's what all the engineers and scientists were worried about. And you know, we were running massive deficits to finance the war and all those things. So, and I would look at the Apollo program, kind of same thing. It was a crisis. It says this is a national priority. We're going to go make this happen, whatever it takes. NASA, you get as much resources as you need. Go execute it. But we don't have that situation today.
So why wouldn't we have that kind of efficiency even during peacetime?
Well, I don't know if we were efficient. I think it was brute force.
We were definitely not efficient.
Yeah, it was brute force.
But we still got new technologies into the field in zip time, in a way that even in the
Well, I think it goes back to I mean, you can also look at the same thing and say, you know, how is it that we did Apollo? How could we put a man on the moon in 10 years? And nowadays we're talking about it's going to be 20, 30 years and probably won't even finish it. We'll look back at it. 5% of the national budget went towards NASA during the Apollo program, and the vast majority of that went to Apollo. Today, the NASA budget is 1/2% of the national budget. You know, if we could put 5% of the national budget towards NASA, we'll go back to the moon, and we'll probably do it even better than Apollo can. But at only 0.5%, no way, not happening.
The question is, would you speak to the issue of counterfeit parts?
Well, we used to watch over it a lot because almost everything we did was for commercial aviation. Everything was FAA certified. And it's true we made a modest profit on the spare parts. And so we were always anxious to make sure that the spare parts were to our specifications and indeed were our parts. And so we surveilled it all the time. We had people out throughout the community. We had the largest supplier to the industry, so we had folks out there, and we were always watching it, always worrying about it, and hardly ever actually saw it as a real problem. Now, I'm a little bit out of date on that, but that was true 5 years ago. So I think it's a big worry. It's more of a worry than a reality, but you do have to surveil it.
Well, we know it is a reality from the recent stuff going on at NASA JPL, but I think it's the exception, not the rule. Yeah. Really.
One more question? Yep.
Would you use them?
Yes, I use them. I do use them, actually. But I try to keep them from not being part of the core part of the team. I mean, that's just, you know, you have to be very careful about what actually is your core specialty and what are things that you're willing to just bring in to help out from time to time. One of the biggest issues with full-time employment versus a consultant is really just a matter of how much work do you have for them to do on an everyday basis going forward for the next 5 to 10 years. Because if you're going to hire a full-time employee, you want them around for 5 to 10 years, at least. I don't know, the couple of government contracts that we've actually had, we actually arranged for the contract to be such that we got a small amount of cash infusion to get going and start on the project, and as we hit milestones, we got additional payments. So that's pretty much the way SpaceX is working with their NASA COTS program contract is, you know, they started off with a little bit of money from NASA, they started the work, and as they hit each milestone, they're getting paid. That seems to be fairly common in our industry. So from the government side of it, you know, if we can get the contracts, we're golden.
Yeah, I can't really speak from a small business point of view, but once we went to milestone-based contracts, our working capital shrunk and our cash jumped. That was the most important thing we did to reduce our working capital. Milestone-based contracts.
Okay, we're coming up on 8 o'clock, so I think we'll wrap it up there, and I want to thank our speakers and panelists for joining us tonight.